In this video, I'm going to explain linear programming problem using graphical method. This is a minimization problem. Minimize z equal to 6x1 plus 9x2, subject to 3x1 plus 6x2 greater than or equal to 24, 9x1 plus 3x2 greater than or equal to 27, where x1 and x2 is greater than 0. We also have the second problem, which says minimize z equal to 8x1 plus 12x2 subject to 4x1 plus 4x2 less than or equal to 32, 4x1 minus 4x2 greater than or equal to 82, 8x1 minus 4x2 greater than or equal to 4. So the difference between this first question and the second question is, here we have two constraints. This is our objective function. With the constraints, we have two constraints. Meanwhile, the second question, which is also a minimization problem, we have three constraints. First of all, we'll be looking at the question with the two constraints, which after that, we move over to the one with three constraints. So here, this is a minimization problem. We have our constraints, which is 2. So let's assume that this is constraint 1 and this is constraint 2. To solve this problem, we need to convert each inequality to an equation. So we have 3x1 plus 6x2 equal to 24, 9x1 plus 3x2 equal to 27 for the second constraint. This is for the first one. For constraint 1, we have 3x1 plus 6x2 equal to 24. Here we need to find the value for x1 when x2 is 0, the same thing to find the value for x2 when x1 is 0. So here, when x1 is 0, what will be the value for our x2? So here we are going to substitute this into this equation. We have 3, 0, because x1 is 0, plus 6x2 equal to 24. Therefore, we have 6x2 equal to 24. So what will be the value for our x2? 24 all over 6. 6 into 6, 1. 6 into 24, we have 4. We also solve when x2, because we've done for the one for x1 equal to 0. So when x2 is 0, what will be the value for our x1? So we are going to still substitute this into this equation. So we have 3x1 plus 6, remember x2 is 0, equal to 24. We have 3x1 equal to 24. So what will be the value for our x1? Is going to be x1 equal to 24 all over 3. 3 into here, 1. Here we have 8. Therefore, x1 is 8. Meanwhile, our x2 is 4. So let's represent it here. We have our x1. We said when x1 is 0, x2 is 4. And when x2 is 0, x1 is 8. After solving your constraint 1, we'll consider constraint 2 also. So this is our constraint 2, 9x1 plus 3x2 equals to 27. For the second constraint, which is constraint 2, we have 9x1 plus 3x2 equal to 27. In this question, we consider when x1 is 0, what will be the value for x2? x1, 0, what will be the value for our x2? Therefore, we substitute this into this equation. We have 9, 0, remember is x1, 0 plus 3x2 equal to 27. Therefore, we have 3x2 equal to 27 Therefore, our x2 will be 27 all over 3, which will give us 9. We also consider when x2 is 0, what will be the value for our x1? We have 9x1 plus, remember we have 3x2, which is 0, equal to 27. We have 9x1 equal to 27. Our x1 will be 27 all over 9, which will give us 3. We have our table here. We have x1. When x1 is 0, x2 is 9. And when x2 is 0, the value for our x1 is 3. When x2 is 0, the value for our x1 is 3. The next step is to represent it on a graph, because this is a graphical method. To represent this on a graph, remember, for our constraint 1, we have when x1 is 0, x2 is 4. When x2 is 0, our x1 is 8. Same with our constraint 2. When x1 is 0, x2 is 9. When x2 is 0, x1 is 3. So we are going to represent it on a graph. This is our graph with x2 here on the y-axis and x1 on the x-axis. Therefore, for the first constraint, we have when x1 is 0, the value for our x2 is 4. We have 4 here. When x2 is 0, the value for our x1 is 8. We join the two lines. This is the first constraint. Same with the second constraint. When x1 is 0, the value for our x2 is 9. We have 9 here. And when x2 is 0, the value for our x1 is 3. We have 3 here. We join the two lines together. The trick to this question is, remember, this is a minimization problem. And the constraints we have greater than or equal to 24 in our first constraint. Second constraint, the same thing, greater than or equal to 27. So the trick here is when the inequality is greater than, our feasible region will be above the line. If our inequality is less than, the feasible region will be below the line. So here we have greater than. So our feasible region will be above the line. So I will show you. This is the graph now. Remember, here is our first constraint. Meanwhile, from here to here is our second constraint. And the two constraints we have greater than. So for the first constraint, we have greater than. As I said, the feasible region will be anything above the line. So everything here is above the line. Everything here is above the line. And for constraint 2, everything here also. And we have 3 corner points. The graph, this is our A. This corner point, this point here is B. And this point here is Z. So look at the corner points from here to here. For A here, we have, remember, x1 is 8 and x2 is 0. x1 is 8. This is our x1, which is 8. And x2 for x2 is 0. Is on the baseline. For corner B, we'll look for the value. So we trace from here. We have 2 here. For our for x1, we have 2. And for x2, we trace also. And we have 3. For corner point B, we have 2 and 3. For A, we have 8, 0. For B, we have 2 and 3. And for C, S2 is 9 and X1 is 0. So X1 is 0, S2 is 9. So for A, we have 8, 0. For B, 2, 3. And for C, 0, 9. We'll represent this value in our objective function to find the optimal solution. For our objective function, we have z equal to 6x1 plus 9x2. We'll be substituting these values in our objective function to know the optimal solution. So a equal to 8 and 0. We have 8 and 0. Here is our x1, here is our x2. Remember, from our graph, our 8 corner points, we have 8 and 0. Therefore, to substitute this into our objective function, we have 6 times 8 plus 9 times 0. And that will give us 6 times 8 is 48 plus 9 times 0 is 0. It will give us 48. For corner B, the value is 2 and 3. Therefore, we have 6 times 2 plus 9 times 3. 6 times 2 is 12 plus 9 times 3, which is 27. When we add the 2, we have 39. For C points, which is 0 and 9, therefore we have 6 times 0 plus 9 times 9, which will give us 81. This problem is a minimization problem. To find our optimal solution, we need to look for the least number. So we have 48, 39, and 81. The least here is 39. For we say the minimum of z is 39, which occurs at x1 equal to 2 and s2 equal to 3. The minimum or optimal of z is 39, which occurs at x1 equals to 2, because this is our least value, and s2 to be 3. So we have our z to be 39. So this is the final solution. So if this video interests you, make sure you hit the subscribe button, like the video, and comment. Thank you. Bye.